Hello dear students, last class we have discussed about oxidation, reduction, oxidizing agent, reducing agent, then last method of finding oxidation number. Okay. Next, today we are going to study the topic redox reaction. Redox reactions. You are familiar with the reactions oxidation and reduction in a chemical reaction. Consider the chemical reaction. Hydrogen and chlorine combine to form hydrogen chloride. In this reaction, which atom undergo oxidation? Which atom? Okay, hydrogen undergo oxidation and chlorine undergo reduction. Okay, these two reactions constitute complete the chemical reaction. This when oxidation and reduction take place, that reaction will become complete. Okay, this type of reactions are known as redox reaction. This type of reactions are known as redox reaction. When oxidation and reduction take place simultaneously, that reactions are known as redox reaction. Here oxidation hydrogen, in the case of hydrogen atom, hydrogen is oxidized and chlorine get reduced. These two types of reaction occurs simultaneously in a chemical reaction. That reactions are known as redox reaction. Here is a question for you in your textbook. First question, H2 plus Cl2 gives 2 HCl. Which atom is oxidized in this reaction? Which atom is oxidized? Here hydrogen undergo oxidation and chlorine undergo reduction. So, which atom is oxidized in this reaction? Hydrogen. The next atom which get reduced, which is the atom? Okay, chlorine is the atom get reduced. Next, here the oxidation and reduction take place simultaneously. This type of reactions are known as redox reaction. Next, consider another example. Mg plus F2 gives MgF2. Next, Na plus Cl2 gives NaCl. In this reaction, magnesium atom is oxidized and fluorine atom is reduced. Oxidation and reduction take place simultaneously. This type of reactions are known as redox reaction. Next, consider next example. Na plus Cl2, sodium combined with the chlorine to form sodium chloride. Here sodium atom is oxidized and chlorine atom is reduced. So, this type of reactions are known as redox reactions. Next topic is rate of chemical reactions. Rate of chemical reactions. Rate of chemical reactions. Okay, there are different types of reactions taking place in your daily life. Okay, some of the reactions are given below in your textbook, page number 54. Some of the chemical reactions are burning of firewood, rusting of iron, bursting of crack. Next, you expand the list, cutting of paper, melting of ice, etc. The some chemical reaction taking place every day in your life. Okay, listen here. First, burning of wood, firewood, burning of firewood. Next, rusting of iron. Rusting of iron. Next, bursting of cracker. Bursting of cracker. Next, cutting of paper, melting of ice, burning of paper, etc. The some chemical reactions. Do these reactions occur in same rate? Do these reactions occur in same rate? No. Rusting of iron is a slow reaction, but in the case of bursting of cracker or burning of firewood, etc., very fast reactions. Next, can you tell me the factors that influence the what are the measures you adopted to make the firewood become easy to burn, or the burning of firewood in faster rate? What are the factors that influence? Okay, first one is given for you, provide more air. When we provide more air, the burning of firewood become faster. Provide more air. Provide more air. Then next factor, can you tell me the next factor? Cut into small pieces. Cut into small pieces. Then next one, add kerosene, etc. The factors which we usually adopted to make the burning of firewood at a faster rate. Okay, next we are going to study some important factors that influence the rate of a or speed of a chemical reaction. Okay, first one is nature of the reactant and the rate of the chemical reaction. First one is nature of the reactant and the rate of the chemical reaction. Nature of the reactants and rate of the chemical reaction. First we take nature. Here is a activity or experiment for you in your textbook. Take a zinc piece and magnesium piece. Take a zinc piece and magnesium piece. Zinc and magnesium. Then take a equal amount of dilute hydrochloric acid in 2 test tube. Take a equal amount of dilute hydrochloric acid in 2 test tube. Then add the zinc piece in first test tube and a magnesium piece in second one. Okay. First you take a 2 test tube, then take a equal amount of dilute hydrochloric acid in 2 test tube, then add in first test tube zinc piece and in second test tube add a magnesium piece. Then record your observation. Okay, you can see that here we take a here we take a equal amount of dilute hydrochloric acid into test tube. Then add first one zinc and second one magnesium. Zinc react with the hydrochloric acid and also magnesium react with the hydrochloric acid. But in the case of magnesium plus hydrochloric acid, the reaction is occurred very fastly compared to zinc with HCl. Here the magnesium react with hydrochloric acid and hydrogen gas is evolved. Here we use the same mass of or same size of equal amount of HCl and equal mass of zinc and magnesium. Okay, but difference is in the nature of the reactant. Here we first we take a zinc and second we take a magnesium. So the reaction rate is different in these two cases. Here is a work for you in your textbook. First zinc and magnesium with a dilute hydrochloric acid and zinc and magnesium react with dilute hydrochloric acid. What are the materials required for this experiment? Can you tell me what are the materials required for this experiment? Okay, 2 test tubes, then dilute hydrochloric acid, then zinc piece and magnesium piece, zinc piece and magnesium piece. Then next, is it necessary to take zinc and magnesium in almost same size? Yes, it is necessary to take zinc and magnesium almost same size. Then can you tell me the procedure for this experiment? Can you tell me or can you write the procedure for this experiment? Okay, first you take a 2 test tube, then add equal amount of hydrochloric acid in 2 test tube, then add magnesium in 1 test tube and zinc in next test tube. Next test tube. Okay, then next question. Which gas is formed during this reaction? You have already studied about the chemical reaction between zinc and HCl or magnesium with HCl, etc. Which is the gas formed during the reaction? Can you tell me? Which is the gas formed when magnesium react with the hydrochloric acid or zinc react with the hydrochloric acid? Okay, zinc react with the hydrochloric acid, ZnCl2 plus H2 is formed. Here, listen here, zinc react with HCl to form zinc chloride and hydrogen. Hydrogen gas is evolved during this reaction. Also, in the case of magnesium, react with the HCl to form magnesium chloride plus hydrogen. Okay. Here in these two cases hydrogen gas is evolved, but there is a difference here. Let us find which gas is formed during this reaction. Which gas is formed? Okay, hydrogen gas is formed. Next question, try to write the chemical equations, experiment 1 and experiment 2. Can you write the chemical equation? Okay, first one, zinc react with the hydrochloric acid and form zinc chloride and hydrogen. Zinc react with the hydrochloric acid and form zinc chloride and hydrogen. The next one, magnesium. Magnesium react with the hydrochloric acid and form magnesium chloride and hydrogen. hydrogen gas is evolved. Okay, the next one, in which test tube the reaction become faster? Okay, zinc, magnesium with HCl, the test tube containing magnesium with HCl, the reaction rate is very fast compared to zinc with HCl. The next one, is there any difference in the concentration of acid used in this experiment? Is there any difference? No, there is no difference in the concentration of HCl acid used in this experiment. What is the factor that influences the rate of the reaction here? What is the factor? Here in first one we use zinc and second case we use magnesium. Here the nature of the reactant are different, or nature of the reactant is one of the factor which influence the rate of the reaction. The nature of the reactant. Here the nature of the reactant are one of the factor which influence the rate of the reaction. First we take a zinc and magnesium piece of same size. Then take equal amount of dilute hydrochloric acid in 2 test tube. Then add in first test tube zinc piece and second one add magnesium piece. Then observe the reaction. You can see hydrogen gas is evolved during the chemical reaction. Zinc and hydrochloric acid react to form zinc and hydrochloric acid react to form zinc chloride and hydrogen. Zinc chloride and hydrogen. Then second case, magnesium react with hydrochloric acid and form magnesium chloride and hydrogen. Okay. In these two cases the concentration of acids are same, but there is a difference in their nature. There is a difference in their nature. Okay. Next factor is concentration and rate of the chemical reaction. Concentration and the rate of the chemical reaction. Okay. Concentration and rate of the reaction. Okay. Here is an experiment for you in your textbook. Okay. Listen. Look at textbook. First one, examine how magnesium react with hydrochloric acid of different concentration. Here is an experiment for you. You should examine the magnesium ribbon or magnesium piece react with hydrochloric acid in different concentration. Okay, magnesium and hydrochloric acid. Okay. Here the materials we needed for this experiments are magnesium, then hydrochloric acid in different concentration, test tubes. Okay. First you take a equal amount of dilute and concentrated hydrochloric acid in separate test tube. Take a equal amount of hydrochloric acid and concentrated hydrochloric acid and dilute hydrochloric acid in separate test tube. Okay, first take a equal amount of dilute hydrochloric acid and concentrated hydrochloric acid in separate test tube. Then add magnesium ribbon in 2 test tubes. Then add magnesium ribbon in 2 test tube. of same size. Care should be taken, the magnesium ribbon should be in same size. Okay. Look at textbook, page number 56. This figure represents the chemical reaction. Magnesium react with the dilute hydrochloric acid and magnesium react with the concentrated hydrochloric acid. First figure indicate magnesium react with the concentrated hydrochloric acid. Magnesium react with the concentrated hydrochloric acid. Magnesium react with the concentrated hydrochloric acid. Here is a more presence of more bubbles, okay. But in the case of second one, we take a dilute hydrochloric acid, okay. In this case magnesium, we take a same size of magnesium ribbon and the bubbles are less. There is a presence of less bubble. That means in these two cases hydrogen gas is evolved, but the reaction is very faster in the case of using concentrated hydrochloric acid. Okay. Here we take two test tube with the dilute hydrochloric acid in one test tube and a concentrated hydrochloric acid in another test tube. Okay. Here is a question for you in your textbook. First one, what are the materials required? What are the materials required? Magnesium ribbon, dilute hydrochloric acid, concentrated hydrochloric acid, test tube. Is it necessary to have magnesium ribbon of equal mass? Yes, it is very necessary. The magnesium ribbon have equal mass. Next, what about the volume of HCl? The volume of HCl should be equal. Okay. Next, look the page number 56. Observe the figure. Observe the figure. Note down your observation. Okay. Test tube 1, magnesium ribbon react very fastly with hydrochloric acid and hydrogen gas is evolved. Then second one, magnesium ribbon react with hydrochloric acid and very slow reaction. Can you write the balanced chemical equation for this reaction? Can you write the balanced chemical equation for this reaction? Okay. First we take a magnesium, then add hydrochloric acid, then form magnesium chloride and hydrogen. Okay. This is the chemical equation of this reaction. Okay, here. Next question. In which test tube the rate of the reaction greater? In which test tube? First one or second one? Okay. First test tube the reaction rate is very greater. Okay. Next, in which test tube contains more HCl molecules? Okay. First test tube or in figure, first test tube contain more HCl molecule. That means when volume, listen here, which test tube contains more HCl molecules per unit volume? Okay, concentrated HCl contain or test tube 1 contain more HCl per unit volume. Okay. Next question, as in increase in number of molecules leads to increase in rate of reaction? As in increase in number of molecules leads to increase in rate of reaction? Okay, Yes, as concentration increases, the number of molecules per unit volume increases and number of effective collision also increases and the rate of reaction increases. The concentration of the reactant increases, the number of molecules per unit volume increases and effective collision also increases. Very important point is when concentration increases, number of effective collision also increases. Effective collision also increases. When concentration of the reactant increases means the number of molecules per unit volume increases. As a result, the effective collision increases. So, the rate of the chemical reaction also increases. Okay. First we take a concentrated HCl and a dilute HCl in two separate test tubes of equal volume. Okay, should be taken of equal volume. Then add one test tube same size of magnesium ribbon in two test tube and observe the changes. The reaction become very fast or greater reaction will occur in first test tube containing concentrated hydrochloric acid compared to dilute hydrochloric acid, the test tube containing concentrated hydrochloric acid with magnesium undergo very greater reaction. That means that when concentration of the reactant increases, the number of molecules per unit volume increases. As a result, the effective collision increases and the rate of the reaction also increases. The rate of the reaction also increases. Okay, you should complete the questions and answers, question answers in your textbook page number 56. Okay, next topic is surface area and rate of chemical reaction. Surface area and rate of chemical reaction. Surface area and rate of a chemical reaction. Here is an experiment for you in your textbook. First one, the reaction between the marble piece or marble powder and marble piece with a dilute hydrochloric acid. The net materials needed for this experiments are 2 beaker dilute hydrochloric acid, dilute hydrochloric acid, marble piece or calcium carbonate piece in powdered form and in piece form. Okay, 2 beaker dilute hydrochloric acid, then marble or calcium carbonate in powdered form and piece. Okay, look at textbook page number 57. This is the experiment. Reaction between dilute hydrochloric acid and marble piece and the reaction between dilute hydrochloric acid and powdered marble. Can you write the procedure of this experiment? Okay. First take a 2 beaker, then take a equal volume of or equal amount of dilute hydrochloric acid in 2 beaker. Then add in 1 beaker marble piece and in next beaker marble powder. They have same mass. two marble pieces, marble piece and marble powder have same mass. Okay. Then next, observe the chemical reaction. Can you tell me or can you write the chemical reaction or chemical equation of that reaction? Okay, here calcium carbonate react with hydrochloric acid. Calcium carbonate means marble react with hydrochloric acid and form calcium chloride plus water plus CO2, carbon dioxide. Calcium carbonate react with hydrochloric acid and form calcium chloride and water plus CO2. Okay. CaCO3 plus CaCO3 plus HCl gives CaCl2 plus H2O plus CO2. Calcium carbonate marble react with hydrochloric acid and form calcium chloride and water and carbon dioxide. Carbon dioxide gas is released when marble react with dilute hydrochloric acid. Here is some questions for you. By observing this chemical reaction, first one, analyze the figure, then write the materials required and the procedure of the experiment. First you analyze the figure and write the materials required and procedure of the experiment. Okay, first what are the materials required for this experiment? Okay, 2 beaker dilute hydrochloric acid, marble piece and marble powder. Then next, what is your observation? Is there any difference in the rate of the reaction in 2 beakers? Can you identify any difference in the rate of the speed of the chemical reaction in 2 beaker? Okay, in first beaker the reaction rate is very slow compared to second one. In second beaker the reaction occur at very fastly compared to first one. The dilute hydrochloric acid react with the powdered marble fastly compared to the first beaker containing dilute hydrochloric acid with the marble piece. Okay. The next one, what about the concentration of acid in both reactions? Concentration of acids are same. Concentration of acids are same. Next one, is there any difference in the mass of the marble? Is there any difference in the mass of the marble? No, there is no difference in the mass of the marble. The next one, what about the surface area of marble? Can you tell me the surface area of the marble? Okay, the surface area is different. When marble piece change into powdered form, the surface area increases. When marble piece change into or converted into powdered form, its surface area increases. Okay. The next one, in which case is the chance for greater number of acid molecule to get contact with the marble in a given time? Which case hydrochloric acid in contact with the particles in marble or calcium carbonate in the form of powdered. In the form of powdered. Okay. The next one, what will happen to the rate of the reaction if marble is further crushed or powdered? What will happen to the rate of this reaction if the marble is further powdered or crushed? The rate of the reaction increases. The rate of the reaction increases. in solid substances, surface area is the important factor that will influence the rate of the reaction. In solid substances, surface area is the important factor that will influence the rate of the reaction. When surface area increases, the rate of the reaction also increases. Okay. Now this is time to wind up my class. Okay, thank you.